When I started preparing for this talk, I felt like I was standing in front of a huge tangled ball of string, trying to find a loose end. Every time I pulled one thread, it led somewhere unexpected. Work, law, film, music, education, robotics, inequality, economics, even philosophy. But that sense of confusion shouldn't be a surprise. It's a sign that AI can't be understood in isolation, but only by following how its threads run through everything else. Because one of the biggest challenges with AI today is that we don't really face it. Too often, it's treated as a novelty, a clever chatbot, a toy image generator, something amusing to play with. And when we do that, we miss the deeper implications. AI isn't a side project anymore. It's already reshaping how we work, how we create, and how we interact with the world. Tonight, I want to take you on a journey. It's a journey that starts comfortably enough, but becomes more challenging the better you understand what AI really is and where it's going. It's a journey from its origins through how it actually works, into the impact it's having on our lives today, and toward where all this is heading: robotics, autonomy, and a future that's coming much faster than we're prepared for. As part of that journey, I want to look at some of the astonishing tools that are currently available to video makers today. And by the end, my hope is that you will see AI not as the end of creativity, but the beginning of a new era, not just for filmmakers, but for humanity itself. The single most important thing to understand about AI is its rate of change. Historically, major technologies evolved slowly. Electricity, cars, aviation, the internet. Breakthroughs happened over decades. We had time to adapt. AI is different. AI advances on monthly timescales. Model capability, computing efficiency, and real-world deployment are all compounding at once. Analysts often describe this as Moore's law on steroids. It's said that 1 year of AI progress can equal decades of normal technological developments. In truth, even that might be generous. Sometimes a single month of progress changes the landscape entirely. If you compare AI image or video generation from just a year ago to what we have today, it's like comparing the Wright brothers' first flight to Concorde. The difference isn't just incremental, it's transformational. That pace matters because it means that none of us are really standing still. Whether we choose to engage or not, the ground is already moving beneath our feet. AI is older than most people realize. The first wave began in the 1940s and 50s with rule-based systems. They were literal instructions. If X happens, then do Y. They worked, but only in very controlled environments. Early robotics followed a similar path in the 1960s. Industrial robot arms in car factories could weld or spray with incredible precision, but they had no understanding of the world around them. The real conceptual breakthrough came in the 1980s, largely driven by visionaries and people like Geoffrey Hinton. Neural networks flipped the idea of programming on its head. Instead of telling a machine what to do, you let it learn for itself from data. At the time, this went nowhere. Computers were too slow, datasets were too small, and neural networks offered no practical advantage. Most of the world abandoned the idea, but a small group, including people like Geoffrey Hinton, persisted. Then in the 2010s, three things collided. GPUs and massive parallel processing became widely available. The internet became a gigantic training dataset, and researchers accepted that hard-coded rules fail in messy real-world environments. That collision lit the fuse. In 2016, the world saw a public turning point. Google's DeepMind AlphaGo defeated Lee Sedol, one of the greatest Go players in history. But the defining moment wasn't the victory. It was move 37 made by AlphaGo. That move looked wrong. It violated centuries of Go strategy. It confused commentators, experts, and even the DeepMind team.
It's just the big shock. What? Normally human will never play this one because it's bad.
Then slowly it became clear the move was brilliant. No human taught AlphaGo that move. It didn't copy it from a database. It emerged from self-play and statistical learning. That was the moment that many researchers realized that AI doesn't just imitate human knowledge. It can generate genuinely novel solutions, ones we only understand after the fact. That's an uncomfortable thought, but a crucial one. AI pioneers who established OpenAI 10 years ago recognized the implications of Move 37. OpenAI's stated mission was to advance digital intelligence in a way that is most likely to benefit humanity as a whole, unconstrained by a need to generate financial return. These early founders recognized the serious risk of AI being dominated by large corporations or governments, and the resulting concentration of power. They recognized the deeper implications of what was likely to occur. And most of today's major players were a part of the original OpenAI leadership. Some left to found or join companies such as Anthropic, Tesla, X, Eureka Labs, Safe Superintelligence, and Google DeepMind. At this point, it's worth grounding ourselves in how modern AI really works. We've already said it doesn't follow rules. It isn't executing a script. Instead, it learns patterns, relationships, and probabilities from a vast amount of data. Large language models predict the next token. It's not quite a word, but a chunk of meaning. And as they scale, they become better at maintaining context across paragraphs, conversations, or even entire documents. The key point is this: AI does not deal in facts. It deals in probabilities. It's a giant probability engine. Images and videos use diffusion models. They work by starting with pure noise and gradually removing it until a coherent image or video emerges. They aren't retrieving pictures, they're generating them. Transformers give AI structure and long-range coherence. They process whole sequences simultaneously, enabling contextual understanding and greater ability at scale. Meaning is represented numerically through weights, a bit like our brain's neurons, billions of values distributed across a matrix. In a very real sense, these weights are the model. AI has no memory drawer it can open. Its memory is a distributed pattern. That's why AI doesn't recall, it generates. This is why every AI system includes a warning. AI can make mistakes. AI is powerful, very powerful, but it's not always a source of truth. One of the quiet technical revolutions in AI is the context window. That's how much information a system can hold at once. As these grow larger, AI systems become less like tools and more like collaborators. Rather than undertake instant tasks, such as giving quick responses to questions, a large context window allows for greater reasoning. AI can then begin to break down problems into smaller tasks and manage them over a longer period of time. Quite simply, it's moving from answering to doing. This leads directly to the idea of autonomous AI agents, an AI achieving complex goals by utilizing multiple models without the need for human intervention. It's almost inevitable that we would see a billion-dollar company run by a single human, supported by dozens or even hundreds of AI agents, handling finance, marketing, development, and operations. In this context, AI can be considered comparable to a natural resource, one whose discovery and control reshape economic and political power. The prosperity of populations has often depended on the extent to which their labour is needed. Resource-rich countries such as Nigeria, the Democratic Republic of the Congo, Iraq or Venezuela can generate vast wealth from commodities like oil or minerals. Because these resources require relatively little human labour, governments often have fewer incentives to develop broad-based education, diversified economies, or equitable labour markets. Economists call this the resource curse. In many cases, the resource wealth benefits a narrow elite, while the majority of citizens see limited gains in living standards. By contrast, nations with few natural resources, for example Japan, South Korea or Singapore, have relied on widespread human capital, innovation, and skills development to drive economic growth. Their prosperity emerged from investing in people and technology rather than extracting commodities. AI could function much like a natural resource. Like oil, it generates enormous value with minimal human effort, automating both manual and cognitive tasks, boosting productivity, and creating new economic outputs. Control over AI, including its data, infrastructure and talent, will determine which actors and nations dominate the 21st century. If control remains concentrated, these gains could flow primarily to a handful of tech firms and wealthy countries. Unlike past technological shifts, AI is advancing rapidly, reshaping labour markets and economic advantage in a compressed timeframe. This resource curse outcome is not inevitable. With deliberate policy choices, investment in human capital, and inclusive governance, AI's benefits could be widely shared. Without such measures, however, the analogy serves as a warning. Concentrated AI could deepen inequality, creating an elite with disproportionate economic and political influence, while leaving the majority with fewer opportunities for meaningful, well-paid work and diminished leverage in the labour market. When we talk about AI displacing work, it's easy to imagine screens and offices. But unlike past technological work, AI is advancing rapidly across both manual and cognitive tasks. Many of the changes are happening in manual labour. It isn't transforming work all at once. It's doing it steadily, task by task. In logistics and warehousing, order picking, sorting, palletizing, and inventory movements are increasingly handled by AI-guided systems using computer vision. In manufacturing, the big shift isn't humanoid robots replacing people overnight. It's smarter automation replacing specific tasks. In agriculture, AI has begun to erode one of labour's last defences, dexterity. Vision-guided harvesters can now identify ripeness and pick fruit with minimal damage. And in construction, even robotic bricklaying systems are becoming a reality. The pattern's clear. AI doesn't replace jobs first, it replaces tasks. And wherever work becomes predictable, repeatable, and observable, displacement follows. In law and compliance, AI now handles document review, case research, and regulatory monitoring. Human judgment is still required, but the volume of routine work has collapsed. In finance, accountants are shifting from data processing to interpretation and advice. In software and IT, the entry barrier has dropped. AI writes code, debugs errors, and tests systems before launch. The role of the developer is moving from writing everything to supervising and steering. In creative work, AI has commoditized the first draft. Translation, technical writing, copy editing, and routine design are now instant. Human value today moves to judgment, tone, originality, and cultural context. Across management, organizations are flattening, impacting the middle managers. Scheduling, coordination, reporting, and market analysis are increasingly handled by autonomous systems. This has profound implications for employment and society, raising the possibility that paid work may no longer be central to economic and social life. And, quite simply, we are not even remotely prepared for it. It's easy to imagine that the founders of OpenAI foresaw this back in 2016, and that it was a major part of their motivation. Their mission statement, advance digital intelligence in a way that is most likely to benefit humanity as a whole, unconstrained by a need to generate financial return, takes on a whole new significance in the light of what has happened over the past decade. And remember, it was OpenAI that first gave the world public access to advanced artificial intelligence just 3 years ago. Whether AI drives inclusive growth or deepens inequality will depend on how it's deployed and, more importantly, who deploys it.